Okay, today we're continuing our rational unit, and we're going to talk about repeating decimals. Repeating decimals are a rational number because you can write it as a fraction. Anything you can write as a fraction is a repeating or is a rational number. So you can convert today between a repeating decimal and a fraction. So here's how. Here's the steps. The first thing you're going to do is assign a variable. I usually call it x. Assign a variable to represent the pattern. That's the first thing you're going to do. What I mean by the pattern, I mean like, is it 0.2 repeat? Is it 0.3 repeat? Is it 0.14 repeat? That's the pattern. The pattern is what keeps repeating. The second thing that you do then is you multiply by a power of 10. You're either going to multiply always by 10 or 100 or 1,000, depending on how many numbers to the pattern. If there's one number to a pattern, you multiply by 10. If there's two numbers to a pattern, you multiply by 100. So the amount of zeros equates to the amount of numbers in the pattern. And then lastly, you're going to get the variable alone. Okay, so let's do the first example. To write 0.3 repeating. Now a lot of kids think, well, 0.3 is 3/10, so there I go, I'm done. But as we realize 0.3 is smaller than 0.3 repeat, because you'd have another 3 and you'd have a 0 there. So they are not the same thing. They are different fractions. All right, so how many numbers? Well, the first thing I need to do is assign a variable. So this is where I say let x equal. What's my pattern? 0.3 repeating. Let x equal 0.3 repeating. This is the first thing I do. Now the second thing I do is I get the pattern to the left-hand side of the decimal. This is known as like scientific notation, because anytime you multiply by 10, it's just moving a decimal over. For example, 5 times 10 is moving the decimal over one spot. It's 50. 5 times 100, now notice the decimal is always right here. It's moving at 2 spots. So I'd have to add the placeholder 0, and that'd be 500. So you need to understand that multiplying by tens is moving a decimal over. So I want to move my decimal over to get the pattern to the left-hand side. So I'm going to say, since there's one number to the pattern, let's multiply x by 10. So 10 times x is equal to 3.3 repeat. Why is that the case? Because it moved the decimal over once, and then I still have all those repeating, don't I? So it turned into 3.3 repeat. But me being able to do that allows me to take the pattern away. So now I say, okay, get rid of the pattern. The pattern is x. Get rid of x. X is 0.3 repeat. 10x, take away an x, is how many x's? 9x equals, notice that cancels out, 3. Now how do you get rid of the 9? This is 9 times x. How do you get rid of times? Divide. X is equal to 1/3. Now, let me explain this one more time. I let x equal a pattern. And I'm going to go through these whole steps again. I let x equal a pattern. The pattern was 0.3 repeat. Notice that 0.3 repeat is really 0.333 all the way to infinity. Am I right? Yeah. So now if I multiply it by 10, getting the pattern to the left-hand side. That just moves my decimal one spot, and I'm left with 3.33333 all the way to infinity. So 3.3. Multiplying by 10 just moves the decimal over. My goal is to get rid of the pattern. That's always my goal, get rid of the pattern. So the pattern was x. That's what I assigned. So I'm going to get rid of it, which is 0.3 repeat. I have 9 x's left. That cancels out. Divide by 9 to get x alone, and you get x is equal to 1/3. Okay, this is heavy stuff. The algebra part of it. With the whole numbers, just like when we converted with whole numbers, you just forget about the whole number and put it to the side when you're done. So now all I'm going to look at here is the 0.72. Don't you cross out the whole number. But all I'm doing is the 0.72, repeating. So I assign, I'm going to let x equal my pattern. What's my pattern? Okay, so what do I need to multiply x by? 10 or 100? How many spots do I need to move it? 2 spots, so I need to multiply by 100. So I'm going to say 100 times x equals 72.72 repeat. It moved my decimal 2 spots, but I'm still repeating to infinity. Now I can get rid of the pattern. So if I get rid of the pattern is x, because that's what I said. I said let x be the pattern. Now I'm going to get rid of it, but the pattern is really 0.72 repeat. $100x, take away an x, I'm left with 99 x's. The 72 comes down because the pattern crossed out. Now to get x alone, I have to divide through by 99. X is equal to 72 over 99. And you must simplify. So some of you might not visualize right away that 9 goes into 72. But of course it does. And it's 8/11ths. That is why a repeating decimal is a rational number, because you can turn a repeating decimal into a fraction. So I know that 0.72 repeat is 8/11ths, but remembering to go back to my original question, because it's really easy not to, we have this lovely 1 in front, and you just bring it back down. 1 and 8/11. So 1.72 repeat is 1 and 8/11ths. Okay, this next one, again, my first step, let x equal the pattern. So x is equal to 0.8 repeat. There's one number to the pattern, so I'm going to times through by 10 to move it to the left-hand side. So 10x is 8.8 repeat. All that does is get my pattern to the left of the decimal. Now I want to take away the pattern. So the pattern was x, which is 0.8 repeat. 9x equals 8. X equals 8/9. Okay, number 2 is going to be a special situation, and you're going to see why. I'm going to let x equal the pattern, which is 0.9 repeat. There's one number to the pattern, so I'm going to multiply by 10. That gets it to the left-hand side. So 10x equals 9.9 repeat. Take the pattern away. The pattern is 0.9 repeat. 9x equals 9. X equals 1. 9/9, which is 1. That is a false statement, but But it really gets close to there, doesn't it? Because if you have 0.9 repeat, it's super, super, super close to 1, isn't it? And 9 just keeps repeating to infinity, which means it almost gets to 1, but not quite there. So this is the only one where when you do it this strategy, it gets you to a whole number. 0.2 repeat. Let x equal the pattern. X is equaling 0.2 repeat. One number to the pattern, so I'm going to multiply through by 10. That brings that number to the left-hand side of the decimal. Now I can take the pattern away. I get 9x equals 2. X equals 2 over 9. Two numbers to the pattern. And number 4. So I need to multiply by 100 because I need to move 2. So let x equal the pattern times through by 100x, which gets a pattern to the left-hand side. Take an x away. I take an x away because that's taking the pattern away. It's making that infinite number infinite. It's taking that decimal out. 99x is equal to 15. X is 15 over 99. Not simplify. Divide them both by 3, and what's that? 5 over 33. Okay, some of you might be noticing the trick. I do the algebra way is stressful. For some of us, get it right away. Some of us, we need to practice it a little bit. It can be a very stressful situation. I challenge you to, even if you get the trick, try the algebra way because it's good skills. So, x needs to equal the pattern. There's two numbers to a pattern, so what am I going to multiply by, 10 or 100? 100x equals 34.34 repeat. Take the pattern away, which is the 0.34 repeat. 99x equals 34. X is 34 over 99. Now I don't know, I feel like, does something go into both of them? So I'm using my divisibility rules. I'm just checking 3 and 9. Because I know 9 goes into this, and I know 3 goes into this, and I know 11 goes into this. For sure, off the top of my head. Well, I know 11 does not go into that. 3 plus 4 is 7, so 3 and 9 doesn't either. So then I know I'm done. And last one, let x equal the pattern. Times through by 100, because that gets the pattern to the left of the decimal. Take the pattern away so you no longer have that repeating decimal. 99x equals 56. X equals 56 over 99. Now I don't know if I'm simplified there either. So I'm doing the divisibility rules. 5 plus 6 is 11. 3 doesn't go into 11. 9 doesn't go into 11. So I would say I am simplified. Got it? Anybody, and I'll share the trick, but I want you to try the algebra way. I want you to try, I don't know how many you have in your homework, but 3 the normal way, and then you can do the rest with a trick. Does anyone want to share the trick? You got it?
I think I know it.
What do you think?
So, the repeating number is always the same. Like, so for the first one, you 8. And then, since it's in the 10th place, it's 1 less than that.
Okay, I think you're right. I think you're right. Michael, how do you think it?
Throw away the decimal, and then you know how you go x minus that, so you take 1,000 or 100 or 10, you subtract